Alright, y'all. So, in number 9, it says, when P is greater than alpha, does the standardized test statistic lie inside or outside the rejection region? Explain your reasoning. So the first thing I wanted to outline is, remember that P is the same as p-value, which is also our probability. Alpha is called the level of significance. Our standardized test statistic, we know that as Z. So we have some conditions as to when we reject or fail to reject the null, comparing the p-value to alpha. So this is different from what we did in class. So here we have another set of conditions on when to reject or fail to reject by comparing the p-value to the level of significance. So when P is less than or equal to alpha, we reject the null. When P is greater than alpha, we fail to reject the null. Okay? So let's take a look at our choices. So answer choice A says that Z will lie inside the rejection region when the standardized test statistic is outside the rejection region. P is less than alpha. B, when P is greater than alpha, it will land outside. When the standardized test statistic is inside the rejection region, P is less than alpha. C, outside. When the standardized test statistic is inside the rejection region, P is greater than alpha. And then D, inside. When the standardized test statistic is outside the rejection region, P is greater than alpha. So we know here that we reject when P is greater than alpha, which is what our problem is saying. We fail to reject the null. The answer here, so we don't just go from what the answer is and let's talk about why. The answer here is outside. Well, it's answer choice B. Outside, when the standardized test statistic is inside the rejection region, P is less than alpha. Our problem says when P is greater than alpha. So when P is greater than alpha, we fail to reject. Let's look at why this is correct. When the standardized test statistic, or Z, is inside the rejection region, P is less than alpha. So when Z is in the shaded area, the rejection region, when it is P is greater than, ours is the opposite of that. So Z would have to be on the outside, because it's only on the inside when this happens, when this condition happens. Let me say that again. The standardized test statistic is on the inside when P is less than the level of significance alpha. But our problem is saying our P is greater than alpha, so it has to be on the outside, because this condition is not happening. Okay? Now, I also want to take a look at a different table about rejecting and failing to reject the null Go ahead and take a moment to write this down, because we will need this for our next problems, our problems afterwards. Let's take time to write that down. Alright, remember you can pause the video and write down what you need. We're moving on. Okay, let's take a look at our number 10. The p-value for a hypothesis test is shown. Use the p-value to decide whether to reject HO or the null when the levels of significance is at 0 and 100, 0 and 500, or 0 tenths. Here's our given p-value. Okay, guys, what we need is this table that we wrote down from number 9. Okay, let's see. So our p-value, p is equal to 0.0991. We need to compare this to each one of the levels of significance that we're given. So let's start off with, we're going to write a statement. P is something to alpha. That's what we're going to write each statement. So let's start off with A. P 0.0991, and our first alpha is 0.01. Well, to compare them, I see that the first numbers are the same. The first number after the decimal is the same, but this second number is a 9. This number is a 1. So it means that this is greater. So 0.0991 is greater than 0.01. So when the p-value is greater than the level of significance, then we fail to reject the null because it is greater. So we're looking for fail to reject. So here, this is out. This is out. Fail to reject the null because the p-value is greater than the level of significance. Or do we fail to reject because the p-value is less than the level of significance? Go back to problem number 9, and we said when p is greater than alpha, we fail to reject the null. So it's because it is greater than. So this is a violation. So our answer here is B. Alright, let's go to B. So write that one. So 0.0991, 0.05. 9 is bigger than 5, so this is also a greater than. So we're looking for a fail to reject. We're going to fail to reject, so we know that A is out and C is out. But now, why are we failing to reject? We're failing to reject because the p-value is greater than the level of significance. So, fail to reject because p-value is greater than the level of significance. Look at the reason D is not our answer. Even though this portion is correct, it is not correct here. That's a violation. So our answer is B here. Okay. Alright, let's check the next one. 0.0991, 0.10. Here, comparing the ones place, that's a 0, they're the same. So I go to the next place value. That is the 10th place. This is a 0, but this is a 1. That means that the p-value is less than the level of significance. So this time I go back to my conditions, and when the p-value is less than or equal to alpha, then we reject the null. So we're looking for a reject. So A is out, and so is D. Let's look here at C. Reject the null because the p-value is greater than the level of significance. Well, that's not even true. That's a violation. So B has to be our answer. Reject the null because the p-value is less than the level of significance, which is a true statement. Okay. All right, let's go on to number 11, I'm sorry. So number 11 is similar in nature to number 10. Here you are comparing your p-value to each level of significance. Pause the video and try these on your own, and then I will come back with the response to see if you got them correct. Alright, let's see what you came up with. So the p-value is 0 and 135 thousandths, 10 thousandths, or p equals 0.0135. So let's compare that to 0.01. Well, since 0.0135 is greater than 0.01, because remember we can write that as 0.0100, and then we're comparing these values. So this one is greater. According to our conditions, we're going to fail to reject because the p-value is greater. Okay? Let's look at the next one. Here, since the p-value of 0.0135 is less than 0.05, we're going to reject because that p-value is less than the level of significance. And then lastly, since the p-value of 0.0135 is less than 0.10, we're going to reject because the p-value is less than the level of significance. So right now this item gives you opportunity just to test your ability to know when to reject and when to test. So we're going to see that being used in a context later on. Alright, let's go to number 12. So here in number 12, it says test the claim about the population mean, mu, at the given level of significance using the given sample statistics. Alright, so once again, test the claim about the population mean, mu, at the given level of significance using the given sample statistics. We have a claim of the mean, or mu, is equal to 50. The level of significance is 0.05. The standard deviation is 3.21. And the sample statistics, or the sample mean, is 48.3. And the sample size is 79. Remember, X bar stands for sample mean. So the first thing, so now we're going to be kind of pulling everything that we've done so far into one problem. The first thing is identify H null and H alternative. So here's our claim. The claim involves equality. So that means that the claim should live in the null. So I'm looking for this being in the null. So I'm going to scan through. I know this is not my answer. This is possible, possible, possible. I know this is definitely not it. This is not it. These are certainly out because they do not involve equality in the null. Remember, the equality lives in the null. Okay? So, now let's look at, so HO is the mean is equal to 50, and that's also the claim. So the complement or the converse of this is I didn't mean the equal sign right there, guys, is that the mean is not equal to 50. So now that I've narrowed it down to 3 items, let's look at those that are still viable. So here is my claim and H null. Let's see, does the complement give us the opposite? It does. So far D is the most correct. Let's make sure the others have violations. So here, notice the null is not the opposite. Notice the alternative is not the opposite of equal. That's a violation. Notice here, again, the alternative of greater than is not the opposite of equal to. So the correct answer is D. Alright? Now, the next part of the question asks us to find the standardized test statistic. And so here is where we begin to bring in what we've talked about with one-tailed test, and now we also have a new formula. So, because our HA involves the not equal to symbol, I know that this is a two-tailed test. Refer back to our notes from number, I believe is number 3. So this is a two-tailed test. And what I know about a two-tailed test is that the p-value is half on one side and half on the other from the standardized test statistic. So I'm going to keep that in mind. So the first thing, because it is a two-tailed test, that I'm going to do is I'm going to find my critical values or my rejection regions. So I'm going to move to some other sheets of paper, guys, so that we can write these notes. Alright, everyone. So I'm going to transfer what we know from our problem on number 12. What we know is that the mean is 50, and that's the claim. We know that the standard deviation is 3.21, otherwise known as sigma. We know that the X bar is 48.3. That's also our sample mean. And the sample size is 79. We also know that the level of significance is 0.05. I apologize for that not being clear. Let me clear that up for you, okay? Focus. Okay, there we go, everybody. Now, what we did say was that we wrote our hypothesis statements. We said that H naught is the mean equals 50 because it involves the equality. That's also our claim. HA is the complement to that, which is the opposite, that the mean would not be equal to 50. We also know that this is a two-tailed test because the H alternative involves the not equal to sign. Now our job is to first find the standardized test statistic. That's what we're about to do now. So the first thing we're going to do is find our critical region. Find the critical region. So I know I need to find the critical region because I have a two-tailed test. So how do I find the critical region? I'm really finding the scores that are on the tail ends, the two tails of the normal distribution. Okay, so I find the critical region by, I know that the critical regions are in two places. One of them is 1/2 of alpha, and the other is 1 minus 1/2 of alpha. I know alpha, remember. Remember, this critical region is on the two-tail test. We're talking about this area here. Okay? And because that's the reason we're doing half. So this side is 1/2 of the level of significance. This side is 1 minus that, because we want to take all of this away to only get this little piece. So that's why we do 1 minus 1/2 of that. It's a two-tailed test, guys, okay? So 1/2 of the level of significance of 0.05 is 0.025. Okay? 1 minus 1/2 of alpha, which would be this value. 1 minus 1/2 of alpha would be 1 minus 0.025, which is 0.9750. So I then take these and I want to find the z-score from my table that corresponds to these values. So normally the z-scores in the table have 4-digit numbers. So I'm going to write this as 0.0250, and this one is already written in 4 decimal places. So let's go to our z-scores. So the first one I'm looking for is 0.0250. 0.0250. So clearly it's not going to be on this positive side because these numbers are too big. So I'm going to go here on the negative. 0.02. That's 2.029. That's too big. Okay, here we go. 0.0250. That corresponds to negative 0.19 and 0.06. So this region is negative 1.96. Well, this should be the opposite of that, but let's confirm. So I'm going to go and find this value on the positive side. 0.9750. 0.9726 right here. 1.96. So do y'all see, guys, that this has to be, because we are on two opposite sides of the graph, the critical region is the one side on the negatives and one on the positive, okay? So let's keep that in mind. The first thing we had to do, because it was a two-tailed test, was find those critical or rejection regions. Now the next thing we're going to do is now find the test statistic. There's a formula for that. The formula says that Z is equal to the sample mean minus the given mean, or the population mean, divided by the standard deviation divided by the square root of the sample. Okay, so let's substitute what we have. Okay, so we know from here, from the problem, our sample mean, we know our mean, we know our standard deviation, and we know our sample size. So that's what we need here. So 48.3 minus 50 divided by 3.21 divided by the square root of 79. Now, for the purpose of my calculator, I'm going to put both parts in parentheses so I'm able to get that entire line calculated at one time. So let's calculate. Let's bring that up. See all of that? Alright, so parenthesis 48.3 minus 50, close the parenthesis. We want that divided by, and this is important because if I don't put parentheses around that entire bottom, the calculator is going to use the order of operations and do what you put in. So I'm going to open up another parenthesis. 3.21 divided by the square root of 79. All right, so we've calculated this Z. Okay. We've calculated this Z. Negative 4.70, we're going to round that to 2 decimal places, so negative 4.71. So let's record that. Negative 4.71. Okay. So now we have found our test statistic. Let's answer our question. Let's go back to our problem. So the problem says the standardized test statistic is, and we just calculated that. We calculated it to be negative 4.71. Negative 4.71. Okay. Now it says determine the critical values. Select the correct choice and fill in the answer to complete the choice. So we know our critical values. Okay. Notice how it was a two-tailed test. So we have 2 critical values. And notice this plus or minus symbol here. Well, let's see. We found that in our work. Negative 1.96, positive 1.96. So that goes here, 1.96. This accommodates for both the positive and the negative in the critical values that we found. So now we need to determine our outcome and our conclusion. So here's where we determine, are we going to reject, are we going to fail to reject. So according to our conditions, remember y'all, our condition says we have some conditions on when we reject or when we fail to reject our null. So look at here, and we compare that to our p-values. We compare that. So we're going to reject the null at the level of 5% significance. That they got that from here. 5%. There is enough evidence to support the claim. Fail to reject at the level of significance. At the level of significance, because there's not enough evidence to support the claim. Fail to reject the null because there's not enough evidence to reject the claim. And reject the null at 5% significance level. There's not enough evidence to reject the claim. I want you to pause and try to come up with your own decision and why. All right. So what did you say? Hopefully you said that we're going to, first, where is the claim? Does the claim live in H naught or does the claim live in H alternative? Since the claim lives in H naught, that means I have enough evidence to reject the claim. So I'm going to reject H naught. So hopefully you chose answer choice D. So let's recap. How did I come up with that? I first had to look back to where is my claim. Is my claim in the null or is my claim in the alternative? Because that gave me an indication on which one I'm going to look for in my table. So that led right here to D. Okay? Alright, let's go to number 13. Alright, in number 13, let's get my paper. Here we have another context. And we're given similar to problem 12. So we have a claim that mu is greater than 1,280 at a level of significance of 0.05 or 5%. With a standard deviation of 200.48 and a standard sample statistic or sample mean at 1,299.96 with a sample size of 200. Okay, just like I did in the other, I'm going to use another paper so I can have enough space. But look at what we're having to do. First thing is identify your null and alternative. Find your standardized, your test statistic. Notice this time they didn't ask for a critical region. They asked for the p-value. And then asked us to make a decision about our claim. Okay. So let's go to number 13. Let's get over here. First thing is let's write out what we know. We know that the mean is 1,000. I'm sorry, the mean is greater than 1,280, right? And that's our claim. We know that our standard deviation is 200.48. Our X bar is 1,299.96, and the sample size is 200. We know that our level of significance is 0.05, which is also 5%. Okay. So, the claim involves the greater than symbol. So that tells me that the claim is HA. That the mean is greater than 1,280. How do I know that? Because it did not involve equality in this symbol. So I write the converse or the complement to that. The mean, if this is greater than, then the complement will be less than or equal to. Okay? I know also, I'm going to also determine what type of test that I will do. I know this has the alternative has a less than symbol. So when I look back at my notes, the less than symbol is a left tail test. Left tail test. It only has one tail. Okay? That means that the p-value is on the left side of the test statistic. Okay? So now we're asked to find I'm sorry y'all, I said the left side. It is I apologize y'all. That's the greater than symbol. So this is a right-tailed test, and the p-value will be on the right side of the test statistic. So our first thing to do, well, that was the first thing to do, was find out what type of test we were going to have. So we determined the test. Okay? It's a right tail test. I know that based off of the symbol that's in HA. Now it's time for me to find our test statistic. Okay, that's Z. Remember, the formula is the sample mean, or X bar, minus the population mean, divided by the standard deviation, divided by the square root of the sample size. Okay, let's go to our calculator. $12.99.96 minus 1280 divided by 200.48 divided by the square root of 200. Alright, and we get this, and we're going to round this to two numbers after the decimal. So 1.41. So Z equals 1.41. Now go to the table. Go to the table. Go to table. And we're looking for 1.41 in our table. Let me get mine. It's a positive, so this time we're so 1.4. Here's 1.4. That's 1.40, 1.41, 0.9207. 0.9207 is our z-score. Now we have to find the p-value. So let's go. Let's fill in our blank. So on the problem, it asks what our standardized test statistic is. That's this number. 1.41. Okay, so let's put that in there. But now we're asked to find the p-value. Notice the difference from the last problem. You had to find critical regions and then find your z, or your test statistic. Here we found the test statistic, and now they're asking for the p-value. Well, how do we find that? We know now that makes us have to think about our type of test. We know in a right-tailed test that the p-value lives on the right side of this z value. So if it's on the right side, then I have to do some subtraction. So to find p-value, since it is a right-tailed test, so that's important, right-tailed, then I have to do 1 minus the corresponding probability, which is this number, to find the p-value that we need. Well, when I subtract that, I get 0.0793. They want us to round it to 3 decimal places. Okay. So we get 0.08. I would think 3 decimal places would be 0 as well, but check how that's entered in your platform, because that's also 0.08. Technically that's 2 decimal places. This one is 3, but see which one, but you get the rounding issue that you need to make sure you consider. Alright, so let's go to our problem. So our p-value is 0.08. Now we have a p-value. We have a level of significance. Let's compare our p-value to the level of significance. So let's compare p-value to alpha. Where our p-value is 0.08. Alpha is 0.05. Clearly, this p-value is greater than the level of significance. That gives us indication on whether or not we will reject or if we will accept our null. That goes back to this from problem number 9. Let's go back to our conditions. When the p-value is less than or equal to alpha, we reject the null. When the p-value is greater than alpha, we fail to reject the null. So what will we do here? Let's look at our problem. So for us, since our p-value was greater than alpha, and just remind you, this is what we had. Oh, I'm sorry, everyone. Since our p-value was greater than alpha, 0.08 was greater than 0.05, we're going to fail to reject the null. So here are our options. We are going to fail to reject. I'm going to highlight that. Fail to reject the null. Now, when we fail to reject the null, now this brings in, how do we know which words to use here? I'm going to use this part. When we fail to reject the null, there is not enough evidence to reject. But that also means to reject the claim. But where is our claim? Our claim, and I'm sorry to be moving all those papers around. Look at where our claim was. Our claim is in the alternative. Okay? So we're making a decision on whether or not we fail or reject, fail to reject or reject. The first thing I looked at is the comparison of the p-value to the level of significance. This told me to fail to reject the null. Now I need to consider, well, where is the claim? That's going to tell me what words to use here. Well, since the claim is NHA and I'm failing to reject the null, I go here. There's not enough evidence to support the claim, and that's the words I use. So I'm failing to reject because there is not enough evidence to support the claim. So y'all, when you're making these decisions here, it's really important that you refer back to the conditions, especially when you're comparing your p-value to the level of significance, and then the conditions that live in your decision making. Where does the claim live? Is it in HO? Is it in HA? Because that's going to determine your wording for your answer choice. Okay? Let's move on. Let's go to number 14. All right, number 14 says, a random sample of 76 eighth grade student scores on a national mathematics assessment test has a mean score of 281. This test results prompts a state school administrator to declare that the mean score for the state's eighth graders on the exam is more than 275. Assume that the population standard deviation is 33. The level of significance is 8% or 0.8, and there's enough evidence to support the claim. Is there enough evidence to support the claim? They ask us a question. Complete parts A through E. So the first thing we need to do is find the claim and then write our hypothesis statement. So be careful, because you would think that the claim lives here and that the mean is 281. The claim actually lives here, where the state results prompt a state school administrator to declare that the mean of the eighth graders on this exam is more than 275. So the claim is that the mean is greater than 275. Will this be our HA or our HO, our null or our alternative? Since it has no mention of equality in here, it goes to our alternative. So HA is that the mean is greater than 275. This is also our claim. The complement to that would be that the mean is less than or equal to 275. So now I can look for, I know my claim lives in the HA. So A can't be my answer. D can't be my answer. C can't be my answer, because they all have the claim in the null, and that's not true. Now let's look for our symbols. We need less than or equal to and greater than, respectively, to represent H null and the alternative. Less than or equal to and greater than. So of the remaining, I see this one's out because it doesn't have the statement of equality. This one has the wrong symbol, and so it has to be this one. Let's look. Less than or equal to, greater than, and the claim is in the right place. So here's our answer. Alright, now we need to find Z using our formula. So I'm going to use another sheet of paper. Let's find Z. If you're using technology to find Z, I think you're going to probably get more of what this answer has. I'm going to do this manually. So this is number 14. So we know that our HO, that the mean is less than or equal to 275. HA, the mean is greater than 275. Our mean, or our claim, identifying everything. Our mean is greater than 275 as the claim. We have a standard deviation of 33. We have a sample mean of 281. We have a sample size of 76 and a level of significance at 8%. So I'm just recapping what we know. Alright. So the first thing is, let's find our Z. The formula says that we take the sample mean and subtract the population mean. Divide that by the standard deviation being divided by the square root of the population or the sample size. I'm putting parentheses for my calculator. Let's go here. (281 minus 275) divided by 33 divided by the square root of 76. And I get 1.59 when I round that to the nearest two numbers after the decimal, to two decimal places. So Z is equal to 1.59, or approximately that. Okay? I'm going to go to my I'm going to write that at 1.59. Okay. The next thing we have to do is find the p-value. Well, what type of test will this one result in? Based off of H alternative, using the greater than symbol, then I know that I'm going to have a right tail test. Okay? So this is a right tailed test. So now I'm going to find my p-value. Find the p-value. Since it's a right tail test, before I can do that, y'all, what do I need? I need to find the corresponding probability that this z-score has. So I go to the table. We got to go to the table. And I'm looking for where this number, what probability corresponds to 1.59. Okay. Here's 1.5, 1.50, 5.1, 5.2, 3, 4, 5, 6, 7, 8, 9. It corresponds to 0.9441. So 0.9441. So to find the p-value for a right tail test, I do 1 minus 0.9441. When I do that, 1 minus 0.9441, I get 0.0559. If I round this, according to the problem, they're asking us to round that p-value to 3 decimal places. So 0.05. I would say that to be 6, y'all. However, in the platform, the calculation became 0.57. So my answer is different from what the platform offered. I believe remember from what we discussed in class, it may be based off of if you find that p-value using your technology versus using this manual method, that may be causing that discrepancy in the thousandth of a point, but I'm not really sure. But just for your own record, for your own reference, we did calculate this. However, in the platform, so on the platform, it registers as this answer. Okay. Now, but at any rate, that doesn't affect the next portion of the problem, which is where we make our determination on what to do. So let's compare. Now let's compare the p-value to the level of significance. So our p-value is 0. And I'm going to use the one that I calculated, 0.056. And we're going to compare that to 0.08. That's the reason I said it doesn't matter, because it's it's a thousandth of a point. So at any rate, this level of significance is much greater than my p-value. So now I go to my table and think about what we have. First thing, all right, let's put it all together. The p-value is less than the level of significance. That's the first condition. We know that when our p-value is less than the level of significance, we reject the null. Now, so that means I immediately go to this decision. But the next thing I want to ask myself is, where is the claim? Is the claim in the null, or is the claim in the alternative? So I go back to our problem, and I see that the claim lives in the alternative. Y'all see that here? This is the claim. So the p-value is less than the level of significance. That makes me reject. But how are we going to interpret it? Since the claim is in the alternative, I want to go to where these meet. So we are rejecting the null because there is enough evidence to support the claim. So let's write that in our answer. Let's see that. Okay. So here, let's finish up. So 0.056, and we are rejecting our null. Now the reason, here's where this part here. At 8% level of significance, or significance level, there is, let's go back and see what we're going to say. There is enough evidence. There is enough evidence to support the administrator's claim that the mean score for the state 8th graders on the exam is more than 275. This, y'all, has to be aligned with what your what that table says. That's going to really help you make sense of which words to use in which context. Okay, last one, and then we'll be done. All right, number 15. Okay. All right. A nutritionist claims that the mean tuna consumption by a person is 3.2 pounds per year. A sample of 70 people shows that the mean tuna consumption by a person is 3.1 pounds per year. Assume that the population standard deviation is 1.21 pounds at a level of significance of 0.1. Can you reject the claim? Let's see what we have. What do we know? The nutritionist claims that the mean consumption is 3.2 pounds. Notice the difference here. This is what for the sample of 3.1 pounds. That's for the sample. But for the population, the nutritionist claims that the mean consumption is 3.2 pounds a year. That's the claim. That the mean is or equals 3.2 pounds per year. Okay? If that's the claim, then does the claim live in the null or in the alternative? Hopefully you said the null because it's an equality. So let's write out our hypothesis statement. H null is what the claim says. Okay? That means H alternative is the opposite of the claim or the complement to that. Not equal to 3.2. Where does that leave us? Well, it can't be this. Not that one. No. 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 Here. These match. We got the right numbers. Here's our hypothesis statement. Alright, let's find Z. What do we know about the type of test that this will involve? We know that this test will be two-tailed. How do I know that, Miss Thomas? Because it involves a not equal to. Okay? So, let's find our Z. Okay. Well, you should be saying, Miss Thomas, in the other problem before we found Z, in a two-tailed test, we need to find our critical region. Let's do that. So I'm going to transfer to another sheet. to continue. Okay. So let's find our critical region. Okay. We do that by taking half of the level of significance. In this case, 1/2 of 0.1, which is 0.05, and I'm going to write that with 4 numbers. So I'm looking for this value in my table. Let's go find the other end, because it's on the left. So remember from our other problem, to find the other critical region, I'm going to do 1 minus 1/2 of alpha. 1 minus this amount, 0.05 equals 0.9500. I need to go to the table to find the values that correspond to these probabilities. Well, I know this one's going to be negative, because look how small that is. Let's go here to the negative, and I'm looking for 0.05, or as close as I can get to it. Alright, let's look for 0.05, 0.01, 0.05. So look right here, y'all. I don't see 0.0500, but I do see that it falls between these two values. So I'm going to remember from last week, when when the probability falls between two values, we take that middle, right? So that middle would be between 0.05 and 0.04. Let's see what that would be on our vertical axis. Negative 1.6 is between 0.5, is between 0.05 and 0.04. So that middle row, or that average, would be negative 1.645. Okay. So these two values here. I'm sorry, y'all. Let's get. I can confirm on the other side, because if I get negative, so we're getting this from the table. Go to table. I'm getting negative 1.645 here. I should get the positive. Let's confirm it. So I'm looking for 0.9500. I see. Look. I don't see it exactly, but it's living right here in between these two numbers. But what are these two numbers? Oh, 1.64 and 1.65. Right there in between them would be that value. So this one is 1.645. Okay. So now that we have that, let's go to our Z. Let's find our Z. So find Z. Remember, Z is equal to our sample mean, in this case 3.1, minus the population mean, which is 3.2, divided by the standard deviation, divided by the square root of the sample. Let's go to our calculator. Yeah, I apologize. I didn't know that was all blurry. Let me get you back. Alright, I apologize, everyone. Let's go here. 3.1 minus 3.2 divided by 1.21 divided by the square root of 70. 70. Did I do square root? The square root of 70. Look at what we get. Here's a negative value. We need two numbers after the decimal, so that's going to put us at negative 0.69. So Z, negative 0.69. Okay? Now what do we do with that? Okay? We now find our p-value. Find the p-value. Let's think about what we know. We know that this is a two-tailed test. We know that the p-value is on either side. So I'm going to put a visual, right? So these little pieces right here would be where the p-values are. So together they make the p-value. So whatever lives here is whatever. I got to combine these two to get this p-value, right? So I also can use, let's look back at the problem that we did similar to this when we found our on a two-tailed test. If you look back to problem 12, we had a two-tailed test, and we found our Z, we found our critical region, and we found our Z score, our Z from the table. Then we found the p-values of them. So I want to try to give this in the simplest way possible for this problem, because it's a little bit simpler than number 12. The p-value is equal to 2 times the area of the Z. Let me write that. P-value equals 2 times the area of Z. Well, where is the area of Z? We find that. Okay. We have to find, I'm sorry, I missed the whole, I forgot to find the area that corresponds to this on our table. So let's stop, let's pause, let me get myself together. Let's go back here to part 2. We found the Z score to be negative 0.69. We need to now go to the table. Go to table. At the table, I'm looking for negative 0.69, and I'm looking for the area that corresponds to that on my table. I know I got to go to the negative. Negative 0.69. That's this right here. Y'all remember the negatives go backwards. There's 9 right here. That's the Z area. 0.2451. 0.2451. Okay. So, why is that significant to us? Because the p-value in a two-tailed test is 2 times the area of that z. So we can say 2 times 0.2451, and that gives us, and go ahead and do that calculation, 0.2451 times 2, that gives us 0.4902. Okay. Now, what do we do with this? We got a p-value. Now we take our p-value and we compare that to the level of significance. Compare it to alpha. 0.4902 compared to the level of significance in this problem, which is 0.1, is greater. Our p-value is greater than the level of significance. What does that mean for us? Let's go to our conditions. When p is greater than the level of significance, that's the first condition. What do? We fail to reject the null. Okay, so that's the first thing, fail to reject the null. But the second thing is, where is the claim? In this problem, our claim lived here in H null. The claim is in the null. So, that's important. Fail to reject, because our p-value was greater than the level of significance, so we're going to fail to reject. I know that my claim is in the null. I come and see where they meet. So now I know why I'm failing to reject the null. I'm going to fail to reject the null. That's my decision. I'm failing to reject the null because there is not enough evidence to reject the claim. Now, instead of claim, I'm going to put the words that are in the problem. So let's go to our problem. Okay. First, let's put in our information. This was negative 0.69. Here we got 0.4902. It was different when I did it in the when I put this in, the platform gave me 0.489, so it's off by 1/100th of a point. Okay, but it doesn't affect what your choice is here. So we are failing to reject the null because our p-value is greater than alpha. So we are failing to reject. So this is out. This is out. Now we need to see why. Why are we failing to reject it? It's because there is not enough evidence to reject the claim. Let's see if this is what that says. Here's our decision. There is sufficient evidence to reject the claim. This is not true. That doesn't follow along with our table. Let's look at this one. We are failing to reject the null, which is based off of our p-value being greater than alpha, because there is not sufficient evidence to reject the claim that the mean tuna consumption is equal to 3.2. We don't have enough evidence to reject that claim. And so answer choice B is our answer. Okay, y'all. Here's just some information for the week. So reminders, and I will send this in an email as well, okay? So homework and self-check for 5.1 will be due on 4/23. Okay. The homework self-check for 5.2 will be due by 4/28. So you won't have as much time. Be due by 4/28. It'll open up after we have class on the 23rd. Okay, but it'll be due on the 28th. Module 5 exam will open. So the window will open from 4/23. That's next class through 4:30 by 11:59. Password will be the same. And then our test, our exam is on 4:30. So make sure you got to be in one place to take it. Okay, on that day. There won't be any other days to take it, I think. Well, we'll talk about that. Okay. All right, everyone. Thank you so much. See you next Saturday.